Okay, we're going to continue on with section 5.3, some more of the problems. And we're going to start with number 7. So tan of 5 pi over 12. Now, there is a tangent formula, but I prefer, and I think it's a little easier, to just do this as a sine and cosine ratio. So remember, tangent of an angle is equal to sine of the angle over cosine of the angle. So we can just use that. And we're going to look at 5 pi over 12. And 5 pi over 12 is the same as 2 pi over 12 plus 3 pi over 12. And 2 pi over 12 is pi over 6. And 3 pi over 12 is pi over 4. So 5 pi over 12 can be rewritten as those. So what we're going to say is the tangent of 5 pi over 12 can be calculated by doing the sine of 5 pi over 12 over the cosine over 5 pi over 12. Okay, now sine of 5 pi over 12 is the sine of 2 pi over 12, which is pi over 6, plus 3 pi over 12, which is pi over 4. And the cosine of 5 pi over 12 is cosine of pi over 6 plus pi over 4. And now I have a sine of u plus v, so u would be pi over 6 and v would be pi over 4. And I have a cosine of u plus v. So we're going to rewrite those with their formulas. So sine of u plus v is sine of u cosine of v plus cosine of u sine of v. Right? So sine of u is pi over 6, cosine of v, pi over 4, right? That's the formula, plus cosine of u, sine of v. So that's the sine of pi over 6 plus pi over 4. And the cosine formula is cosine of u, cosine of v, minus sine of u, sine of v. Okay, now we're going to plug in the numbers from the unit circle. Sine of pi over 6 is 1/2. Cosine of pi over 4 is root 2 over 2. Minus cosine of pi over 6 is root 3 over 2. Sine of pi over 4 is root 2 over 2. Over. Cosine of pi over 6 is root 3 over 2. Cosine of pi over 4 is root 2 over 2. Minus sine of pi over 6, which is 1/2. Sine of pi over 4, which is root 2 over 2. Now, we can go ahead and do this out. And I'm going to do it out over to the right because I want to show you a simplifying trick that you might find useful, which is why I like to use this formula and not the tangent formula that the book presents as an alternate. So the top of this becomes root 2 over 4 minus root 6 over 4. And the bottom becomes root 6 over 4 plus root 2 over 4, minus, sorry. Oh, the top is a plus, sorry. I knew there was a plus here. This plus, I needed to put a plus there. And the bottom becomes root 6 over 4 minus root 2 over 4. And that becomes root 2 plus root 6 over 4 over root 6 minus root 2 over 4. And because I have a 4 on the bottom of both, I can do root 2 plus root 6 over root 6 minus root 2. And now I need to rationalize the denominator of that. So we're not quite done there. But if I take this and I look and I say, hey, there's a root 2 over 2 in every piece, what that allows me to do is to rewrite this fraction and factor the root 2 over 2 out. So the first one becomes 1/2 plus root 3 over 2. When I factor root 2 over 2 out of the numerator, I'm left with those two pieces inside. When I factor a root 2 over 2 out of the denominator, I'm left with root 3 over 2 minus 1/2. Okay, so basically I'm factoring, like this would be very similar to if I had said AB plus AC over AD plus AF. Right? I can take an A out of the top and I'm left with B plus C. And I can take an A out of the bottom and I'm left with D plus F. And that's pretty much what that step is doing if you don't see that as quickly as some people. Now, because there's a root 2 over 2 on the numerator and the denominator, that's going to cancel. That root 2 over 2 and that root 2 over cancel. And so now we're left with 1 plus root 3 over 2 over root 3 minus 1 over 2. And I have a fraction over a fraction with the same denominators. So I end up with 1 plus root 3 over root 3 minus 1. Now, I still have to rationalize the denominator, but that's a lot simpler than this one up here. So I like to look and see if I can factor something out at the start. Now, how do I rationalize the denominator? Well, I multiply by the complex conjugate. So just in case you forget how to do that, I'll remind you here, right? So this is the answer. This is tan of 5 pi over 12. But it's not really in the simplest form in terms of math. So we're going to just remind ourselves, how do we get that so that there's no radical on the bottom? And the way we do it is we multiply it by a fraction that equals 1, right? So the numerator and the denominator are the same. And we multiply it by the complex conjugate of the bottom, root 3 plus 1. But not the complex conjugate, just the conjugate with the radical. So we change that minus to a plus. There's no complex numbers. And the top is root 3 plus 1. Okay, so that fraction is 1. And by putting the opposite sign in between the radicals, we're going to end up with only a rational number on the bottom. So root 3 times root 3 is 3. Root 3 times 1 is plus root 3. Minus 1 times root 3 is minus root 3. So those go away, and I get 3 minus 1 on the bottom, which is nice because that's 2. And on the top, I get 1 times root 3. So I'm going to get root 3, 1 times 1, and then plus root 3 times root 3 is 3, and then plus root 3 times 1 is root 3. And so on the top, I get 4 plus 2 root 3. And then that simplifies. That 2 can get divided into both pieces, so that becomes 2 plus the square root of 3. So that's the simplest form of the tangent of 5 pi over 12. And you really should know how to simplify radicals, simplify a fraction when there's a radical on the bottom. You should be able to do that by multiplying by its conjugate. Okay, so now let's take a look at number 9. Move this book over a little bit. All right, so number 9 says, find the cosine of 7 pi over 12. And I'm going to say that's the same as the cosine of 3 pi over 12, because I know that's pi over 4, plus 4 pi over 12, and I know that that's pi over 3, right? So this is the same as cosine of pi over 4 plus pi over 3. So I have a u plus v. So that's going to be cosine of u, cosine of pi over 4, cosine of v, cosine of pi over 3, minus, that's the formula, when I have a cosine of u plus v, there's a minus here, sine of u, sine of v. Say, cosine of pi over 4 is root 2 over 2. Cosine of pi over 3 is 1/2. Minus sine of pi over 4, root 2 over 2. Sine of pi over 3, root 3 over 2. So I get root 2 over 4 minus root 6 over 4, which is equal to root 2 minus root 6 over 4. And so that's the answer to cosine of 7 pi over 12. So if I typed this number into my calculator, it would be the same number as if I asked the calculator to tell me what the cosine of 7 pi over 12 is. Okay, now the next two are pretty quick, so we'll do those two on this video, and then I'll start another video for the next ones. So number 11 says, if you have this expression, sine of 42 degrees cosine of 17 degrees minus cosine of 42 degrees sine of 17 degrees, write that as the sine or cosine of one angle. So what this is asking us is to fit this into one of our formulas. So this is a formula like sine of u cosine of v minus cosine of u sine of v. So I want to go back and look at my formulas and say, which formula is that? Well, that's equal to sine of u minus v. And if I match my letters up, 42 degrees is u, 17 degrees is v. And in this case, u is still 42, v is 17. And so this becomes sine of 42 degrees minus 17 degrees. And so that would equal the same number as the sine of 25 degrees, because 42 minus 17 is 25. Okay, and then we'll do number 13, very similar to that one. So 13 says find one sine or cosine that's equal to sine of pi over 5, cosine of pi over 2, plus sine of pi over 2, cosine of pi over 5. Okay, so this is a sine of u plus v. Sine u plus v is equal to sine of u cosine of v plus cosine of u sine of v. So if u is pi over 5 and v is pi over 2, well, cosine of u sine of v, it's just written backwards. It's still the same. Cosine of pi over 5 if u is pi over 5 and sine of v. So that's still, this makes sense still. Okay, so we're going to say that in this case, this would be the sine of u plus v, pi over 5 plus pi over 2. And I need a common denominator, so that's 2 pi over 10 plus 5 pi over 10. And so that's 7 pi over 10. And so on number 13, that long expression is the same as sine of 7 pi over 10. And you could try it. You could type sine of 7 pi over 10 in your calculator in radian mode. And then you could type this expression in, sine of pi over 5, cosine of pi over 2, plus sine of pi over 2, cosine of pi over 5, and you'd find that it equals the same number. Okay? And you can continue on with the rest of the problems on the next video.